Well, hi, good morning. Thank you so much for joining me in my shop. Today is August 7th, and the drought continues. In fact, there's kind of drought conditions right across Canada right now. A lot of lack of rain. So, and of course, I have my buddy here getting ready to walk on the keyboard. Part of his morning routine. Okay, so I think the evidence is pretty clear that the local oscillator circuit in this radio is not producing a local oscillation. So that's the focus. Now, how do you deal with this? Well, if the parts were more exposed, I would be busily checking parts and stuff like that. But the parts are up inside this box, tucked up underneath this tube socket. And they're not accessible at all, really. As far as I know, they're not accessible at all unless you remove the tumbler that's inside here. And that's a step I'm not interested in taking right now. So what other things could be done? What other things could be done? I don't know. I don't know. There must be some things we can do. I thought I had something in my head last night that came to mind that could be done. Change the tube. Put a different tube in there. Put a tube in there from a radio that's working and see if that makes a difference. Why don't we start right off with that? That would be a good idea. Okay, so here's a tube from the working radio. 1L6, it says right on it. I put a nice little check mark on it so I can't confuse it with this one. Now this might make a big difference. It is possible for these tubes to test okay in a tube tester, yet won't support an oscillator. Put this tube, put it in there. So often in repairing a radio like this, swapping the oscillator tube is required. No amount of testing is going to prove things one way or the other. This is from the other, no, this is from this radio. The other radio has two of these on these positions, not one like this. It doesn't feel like it's grounding very well. That would be bad. If this is not grounding, it's even worse to have it on. The shape of it doesn't seem to be quite right. Just enough contact there. Keep an eye on that. Oh, Wally, what are you doing here? So this is my other cat. You usually see Bert. This is Wally here. He's a little more of a Holstein. He has this white patch on his back, and he doesn't come in here nearly as much. How come? Oh, fur flying here, buddy. We gotta give you a brush out. Okay, so I have the tube in, and we're gonna want the antenna booster here. Wally, you're not so familiar with what goes on in the shop because you're never in here. Set here. I think so. Okay, volume is a little bit up. What do you... Come on, what are you doing? He's found the bag. You want the bag to play with? Here. Down here. Here it is. There we go. Okay, sorry about that, but that'll take care of him. Okay, I'm going to power this on. Now we're in the broadcast band, pretty sure. And there's no reception, so I put the booster in. Well, that answers the question right there. It's overloaded. Interesting, I can overload it. Oh, you don't see what I'm doing here. This is what I'm doing. This is hooked up to my outdoor antenna, a powered antenna, and I'm just throwing it near the coil, near the antenna. Much bigger effect than this other tube. The radio is now receiving. You probably can't hear it, but I can hear it. Now it could be even because this is just anywhere in the area. How accurate is this? Okay, this is good. This is Hamilton, 820. This is 860. Okay, with no antenna boost. Still extremely weak radio. Putting a new tube in has helped a bit. Well, it could be that the tube is weak and other stuff too. I should leave this tube in for now. And a what? And a what? It's possible the front end alignment is horrendously bad. Maybe we should take a look at poking around with that a little bit and just see if there isn't some horrendous thing I'd mentioned earlier. Maybe somebody twiddled these. You can only twiddle these if you take the whole chassis out. Did somebody do that? There's not much else here to fiddle around with. So I don't know, that's not very hopeful. Going after components. So I did a little bit of work here with an ohm meter. Couldn't find anything curious. Gotta stop and think about it. Well, let me recapitulate a little bit. Despite changing this tube, and despite the weakness in the radio tunes roughly the right place on the dial. I find that a little bit surprising. I would think anyway, if there's some serious component issue going on with the oscillator circuit, the oscillator frequency would be well off and the dial would be well off. But that's not the case. And it appears as if the oscillator is oscillating correctly. It's just the result is not passing into the radio. Now, how can this happen? How could this possibly happen? The oscillator is dependent upon the operation of this tube, and if the oscillator is operating, the tube should be operating. Where am I going with that? I guess where I'm tending to go with that is that the problem has to be between the output of the oscillator and the input of the next critical step, whatever that is. Well, let's look at the schematic here. I'm just staring at the radio, it's not helping much. Okay, so if we look at the oscillator tube, the actual oscillator circuit would be between, oh, that's right, I got a bad measurement here when I measured this. Anyway, the oscillation would be between this grid and probably this grid right here, right next to it, the next grid up, which would normally be a screen grid. I'm not sure of that. This is a negative. This is a negative lead, so no, that can't be, I don't think. So it must be the third grid up, acting as a plate. So yeah, you sort of have a tube running here, and then the whole tube running. And the idea is this little internal tube, if you like, is the amplifier for the oscillator. We keep the oscillator oscillating. And because it's operating right here, it affects the electron flow going through the entire tube. And then the signal from the antenna is coming in here onto this grid, and it's encountering this already modified current flow through the tube because of the local oscillator running, and it just kind of adds its part in. They get mixed up in here. Part of this has to do with non-linear operation in the tube, I think. Maybe not. I could be mistaken about that. But sometimes you can mix signals together if they are together in a non-linear circuit. Usually, I believe the oscillator is blasting too. It's just screaming inside this tube compared to the other signal, compared to the antenna signal, strength-wise. So so if the oscillator is running well, then this little amplifier circuit is operating fine, and the problem lies elsewhere. Where would that be? I should check these voltages again, just to be sure. And the output of the tube, there's no components. It's straight up to my favorite transformer, the one I replaced. The only thing in the plate circuit here, the only resistive yeah, I guess you could say resistive element is this winding. So I'm wondering about the significant difference between the two transformers, the one I've installed and the one that I removed. Is that a permanent variation in the radio's operation? So in other words, the transformer I have in there now is guaranteed to not work as well as the last one for reasons we could guess at. What if that's the case? Did I ever, how do you even judge that? You'd almost have to tap the signal off of here and somehow come to grips with whether it's strong or not. Well, one way would be if I did tap the signal here with my signal tracer and listen to it and compare it to what's coming out way down here out of the radio speaker in terms of strength. I could find with my tracer this is very strong, and out here it's not, and we could guessed this is really the problem now. On the other hand, if I listen to the signal here using my signal tracer, and it sounds pretty similar to what's coming out of the speaker, then we know that all this is working and the problem lies back here. That sounds like a test worth trying. Okay. Having such a nice time in here with my cat, I thought I'd share it. Just getting ready to do the tracer test here. Practicing here, so we're just going to be touching this here. What was that? Is there another cat in here? Who's doing that sound? So we want to listen. This is not on or anything like that. We want to listen here. Going to tell us, and then we want to compare it to what's coming out of the speaker. I almost forgot what my objective was. Okay. Are you ready, cat? Now, I think we need to have the booster, the antenna booster going, so we have something to chew on here. Is that right? I'll get it close anyway. So this is not in the strongest spot, but there we go. No, that's not for you. I didn't put that there for you. Okay. What's left here? Don't. You took the bag off this. I had a bag on this specifically so you wouldn't put it in your mouth. And then you stole the bag. Who stole the bag? Okay, I see the bag. Wait here. Wait there. That was your brother who took the bag off. You leave the bag on there, okay? Don't show so much interest. Are we ready? Okay, I think we're ready here. Oh my gosh, I don't want to do this with him right here. No, I'm gonna go play with him for a bit. He's in the mood, and then we'll do the test. Okay, let's give this a go. Now, if you hear a bit of a hum right now, that's coming from the signal tracer over here, if you can hear it. I'm going to turn this on, it'll add a little bit of a hum. It's tuned to the French station, as I remember right. We should be able to hear it out of the speaker. I'm not sure what I'm doing here. Let's just do it. Oh, for crying out loud. I thought you took off and went to sleep. How come you're back here now? There we are. So, question is, again, I'm not sure how to judge this. Let's listen. I'm gonna dial up 860 on this. B. Come on, cat. 860. Let's read around in here. No. You know what, mister? I'm going to have to get you out of here during this. Don't give me the look. What do you mean I have to leave? Yes, you're going to have to go. Oh, that's not what I want you to do right there. That's exactly why you got to go. Come on. Okay, you're leaving. Okay, we hear it like this. The volume is That's about halfway up. Okay, now we're going to listen on here. What do we hear? Tune over here. Whoops. Wait a minute. To make sure there's no mysteries as to what's happening in here. Okay, back on the blue wire. Listen to the signal to noise ratio here. Make sure the radio's tuned. Mes processus créatifs les plus efficaces, ceux qui sont mieux déroulés, ça a été ceux où je parlais le moins. Just a very little bit of background hiss. This is just as good. So the signal coming out of the speaker is imitating the signal I'm picking up here. We take away the boost. How could it be any different? There's just nothing. There's going to be nothing. Oops. This time. So what that indicates then is the weakness is ahead of this blue wire. I think that's what I'm proving out here. Because if you can get a good signal to this point, it comes out of the speaker. Does that make sense, what I'm saying? No. You know what? That could be true anywhere in the circuit. Couldn't it? Oh my gosh. Blame it on the cats. I gotta go drink some more coffee here. Why don't we consider a different approach at this point? Maybe forced into it anyway. So again, all this stuff here is buried inside the metal box. You can see the dotted line going around here, and is virtually inaccessible without taking. It is inaccessible without taking a fair bit of the tumbler part of the tuner apart. I think the tumbler has to come right out. The front has to come off the radio. I don't think this is a simple thing at all to get access to a part like that. So, but just ignoring that for a minute and not worrying about it, just consider, let's look at the circuit path or try to follow the simplest circuit path. How can you get to this grid quickly? And you can see there is a path right here through this capacitor and through this capacitor, and you're right on the grid here. You're not, if you get on, if you come in through this, then you're heading up into all this stuff. Now I'm fooling around. Now, why did they even make this available to external antenna and ground whip antenna? So maybe what's happened here is the whip antenna presents a certain kind of impedance to the radio, and they've designed circuits to support a whip antenna, very high impedance antenna, I'm sure. Alternate antennas, longer wire antennas and other stuff have lower impedances, so maybe they've decided. And they also have a little more boost. Like this antenna is only so long. There's a long one, but it's only so long. There's an outdoor antenna, it can be 10 times as long. 10 times the signal coming in here. I don't know, that doesn't make 100% sense to me. This still goes up, Jim. This still goes up. So there's still stuff going on up here. And interesting enough, if you come in this way, you must come out over here. You bypass this capacitor. So if we move the antenna from here, or the input signal, whatever it might be, from here to here, what kind of difference should we get? I wouldn't think a lot. Now, the difficulty here is, does this work on broadcast band at all? Because the radio's designed to work with these loop antennas up here. Interesting, this coil. I know where this coil is. they're showing 3 different antennas here? Well, there's only 2. How come they're showing 3? There's only 2 different kinds of antennas. Maybe one of them is an option or something you could buy. This loop antenna maybe is an option. Oh, it says which radio it goes with. I don't know. Okay, going back to this little area then. We can try this and see what the difference is and then think harder about it afterwards. What I would really be looking for though is a way to get the signal to this grid that bypasses everything up in here, and we can hear clearly what happens when you energize this grid. And we can start by going through these capacitors, but I should really want to contact this with an actual antenna signal, because look, it's just capacitors away. Could I do that, or am I disturbing the radio so much that the test is automatically false? Because I'm just working with such a weird situation. I wish I could get at all these parts underneath here easily, but that's not possible. I can put the tube extender in and get at the pins here, so I can get at this spot. So I could potentially just feed an antenna signal right into here and see if it's, you know, much louder. And I don't really need to use an antenna. Use a signal generator or do it with a controlled signal into here. Okay, that's a plan. That's something. I can try. So I pulled out the tube to put on the extender here, and I thought, you know what, why don't we test this tube again? Because, you know, if this is weak, maybe I was wrong in my earlier test. Maybe, and I don't like the maybe. So I'm going to get rid of the maybe here. So this should be set. Let's just double check. 1U4, 1.5 volts. Signal level 2, bias set to 0, 7340K, 7340K, and 5600, 5600, 43 here, plate voltage C, very good. Procedure, which is to start with this over here. So there's an F written in the remarks here, which means you can expect this to happen on setting 1. Okay, there's no shorts. This tube is got to be above, looks like 580, so 580 would be right here. Well above, it's well above. So this guy is not causing us problems. This is not weak enough to explain anything. In fact, it looks really good. There we are. Now the objective will be, what is the objective here? The objective was go and have some coffee for a moment. That's my objective. Okay, so the radio is tuned to 860, so I'm going to want my signal generator running around 860 also. Good guess, 860. Okay, that's 860. Now, the signal level here is similar to a strong antenna. It'd be kind of similar to what is coming in on my external antenna wire that I keep using. I have the output here. Oh my gosh, look who's just showed up. Where'd you come from? I thought you had gone to sleep. No, eh? Okay, try not to cause problems. The radio's not on right now, so we're okay. So this is the output from the signal generator onto the end of this probe. What I can do with the round off to start, onto the antenna, onto pin 6. And we'll see if there's a difference there. Okay. You gonna settle down there? Good show, Bert. Just settle right in. Okay. Switch on the radio. And what am I not thinking of? Yeah, radio's tuned to 860, so we should be okay. In fact, I can prove that when we start. Okay, here we go. Radio on. Radio's on. Yes, it is. Just turn the volume very low. Okay, proving this is working and it's tuned. Okay, now we're taking the signal generator signal of the same frequency. Just ignore my counter, it goes wild now and then. Not much of a signal. Oh. Okay, there's the tone. Get an idea of the volume. Wow. That didn't work out so good. So problem here. I'm going to ground this and we'll see if we get rid of that hump. I'm not sure that's going to work. Where do you want to ground it? Something good. There's really not a lot of good places. Okay, back. Antenna. Wow, hard to make a contact. There we are. Do you hear it? Same level. It has a hum involved in it, but we won't worry about that. That's just from the arrangement here, I think. Sound the same? I would say so, except for the inner mod. There's another antenna input here. This one here. Quieter on that one. And then what about putting it right into here? How come nothing here at all? I get nothing here. This is probably grounded. We'll look at the antenna circuit for what's coming up here. What about this capacitor? Let's just take a look at this wiring situation and see if we can understand why we can't hear anything when we touch one side. Good idea? Bert? What do you think? Yeah? You like that idea? Sure, man, whatever you say. Okay, let's take a look. So, over here on the antenna, so what I found is if I touch here, or if I touch here, I get the same thing. Except there's a hum introduced here. And I'm not sure, wow, it's not much of a difference. How come the hum here and no hum there? That's an interesting question in itself, but I have no answer. So we could put the signal in here. We could do the same comparison. I only have one tube extender though. But we know now the sound in pin 6 is the same as the sound here on this. So we could listen to here, the input to this tube, and compare it. Well, we can compare it right back to the input into the radio. So that'd be pin 6 on the oscillator. Or you know what, I could do it on pin 2 right now, because the way things are, I can go to pin 2. I should go pin 6 and then pin 2 and see what the difference is. Yeah. pin 6 and pin 2. Wait a minute, I'm thinking two things at once here, and I shouldn't be. I'm thinking input and output. I'm thinking signal tracer. While I'm thinking about this, I got it backwards in my head. So we're putting in a signal. So what if I put a signal in to that 70 volt line? I run the risk of damaging my signal generator. But I do have a capacitor in the circuit. I actually don't really run too much of a risk. So that would be pin 2. I was going to read the voltages on it, and I'm confusing myself as to which tube I've got up here. I am just becoming too easy to confuse these days. Okay, let's just check those voltages, because we have everything here to do it. So we should do that. My very patient cat there. I'll read these to the B minus. Clip this clip onto the B minus. Thinking hard. You can hear the musical tube all the time. Any little knock on the bench, it rings in the tube. Okay, so this is a voltage measurement here. My tabletop cords. Make that happen. Okay, and let me just see which one is it now. We want to look at first the pin number 2, which is going to have the plate voltage on it. Pin number 2. That's way back around here. I think this is 2 here. So we see 63, and what it's supposed to be is 70, and we're feeding the radio today with 102 volts. We're way low. How come so low? Not going to make much difference. Did I read that wrong? 112 volts now, and the reading on the meter is 65, and the target is 70. Well, I don't think that's going to explain a problem. And now pin number 3 should have 88 volts on it. Have higher voltage on pin number 3. So this would be 3. 85. 2. 65. 85. And what they should be is 70 and 88. So that it sounds like the right ratio, just a little low on the voltage. It's pin number 6. Pin number 6 should have 1.6 volts on it. Pin number 6. So that would be 7.6. Yeah, right there. 1.2 volts. Positive. It should be 1.6. Well, yeah. I don't think that's going to be a problem. Okay, well, that didn't prove much, but except that the voltages are there. Okay, remember this is B minus hanging out here now. Okay, let's go back to injecting signals here. So if we inject into the grid, that's this one here. We hear that. Now we're going to try and inject into the grid of the next tube by touching the plate of this tube. So with this much signal, whatever I've got on here, pin number 2. Might be a bit of a pop here. Hope I don't blow up my signal generator. Well, there's nothing at all. Barely, I think I barely hear it. So that's not too surprising. We're going through an amplifier, starting with a weak signal, and it's amplified and we hear it. If I go on the output side of things, I'm absolutely sure that is pin 2. Absolutely sure pin 2 is the one. We would need a stronger input signal. So that's 10 times as strong now. There we hear it. Now, what once this proved. I think it says everything's okay to hear. Ooh. Now, so this is the output coming from V101. We should match this with the input to V102. I have to move the tube extender to do it. Once I move it, you really can't, like, you can't compare. Look, this is so strong now, just getting it close. So the question would be, what is the question? What's the question? What, we're going to look at this? We were going to look at this, and I don't think I ever did. Okay, okay, slow down, Bert. Calm down. Let's take a look at what we intended to look at here. We wanted to look at, so this is the capacitor here. Green dot. Green dot. I wonder why they would do that, because it's polarized by the way they've arranged the pins here. Why the green dot? Green dot. Well, if we look here, we can see that the green dot is going into the circuit. This would go. All three of these go in here. So one side and the other side, look, it's just grounded. So that's why. That's why if I feed a signal into this grounded terminal, you don't hear anything, because it's just grounded away. So that explains that. Do we know for sure that this antenna is succeeding in feeding its signal all the way to this tube? That the weakness is really right from up here. I did put the signal in up here and heard it. I'm going to repeat that right now. Oh yeah, I just had to get it close and you could hear it. Well, what's the problem then? Well, the problem, I have a very, very strong signal on that pin. That's what it is. So, okay, so all seems good, except we don't know for sure that what's coming out of here, which seems good, is what's arriving over here. So we need to do this test, and I need to have some calibrated way of doing it. So what I could do is I could put the input on the antenna, turn the signal level down until it's tolerable, calibrate, and then move it over here. Well, what would that do? So we should put a weak signal in here, boost it there. It doesn't make sense. I should really do it here, because we should get the same result. Touching here should give the same result as touching here. So get it, calibrate here, and then go there. Make sure. Okay, calibrate. Ooh, that's too high. Let's try that. Plate. Maybe a little higher than that. So I want to find the same level of signal on the grid to this tube. So I have to remember this. I'm not using meters, I'm using my head. Ooh, that's bad. I'm using my ears. Got it? Okay, we have to let this cool a little bit. These don't get very hot. There's no heat in them at all. They don't have to cool. Okay. Come out. Come out. Okay, now practicing. You remember what the tone was, and we are going to want to look at pin number 6 to see if the same level is there. Pin number 6 is 7, 6. This is 6 here. What do we want to look at? We don't want to look at, we want to feed in and listen. That's what we want to do. Feed into 6. Is it the same? Okay, let's do it. Six. It's about the same level, wouldn't you say? You know, it's just, the whole front end does not appear to be weak. Right up to here, pin 6 again. I'm feeding into the grid. I'm feeding in the same signal that I was feeding in at the plate here. Just basically a wire going from here through a capacitor over to here. I get the same sound. How come that seemed louder? Did I pick the wrong one? I did pick the wrong. Oh, what did I pick there? I picked pin number 7. What did I do by accident? Pin 7 is a heater pin. So basically, I don't know how to interpret that. Sticking the signal into the heater, the cathode. You stick the signal into the cathode, you get a stronger output than you do if you stick it into the grid. And what about grid 4? Or pin 4, the oscillator grid. We're going to measure the voltage on that now, because that's the one that measured low before. Or wrong, I should just say wrong. And we're getting down to it here. Try not to disturb my cat too much. I didn't find a very, quiet place to go, Bert. Okay, what are we doing? We're looking at the voltage on pin 4 as measured to the B minus. Okay, so B minus clip here. Pin 4. So we count these. 7, 6, 5. This is pin 4. So we're getting 0.1 volts positive, and we're supposed to get minus 3 volts negative in this test. Pin 4, I'm on the wrong pin. Am I on the wrong pin? 7, 6, 5, 4. No, I'm not. Okay, some other voltages worth measuring while we're here. Pin 2, 91 volts. Pin 2, 91 volts. Pin 5, 46 volts. Pin 5, 765, 46 volts. And right on. Pin number 3, 66 volts. Pin 3. Where is that one? 7, 6, 5, 4, 3. Supposed to have 66 volts. I got 68. Pin 1, 3.1 volts. This is the heater. Pin 1, 4.3. And pin 7, 4.6. Pin 7. Oop. I must have read that wrong. Mixer oscillator should be 3.1 on one side and 4.6. Roughly a volt and a half. Should be a volt and a half difference. That's really what's important, I guess. So here we get 2.8. So that's 2.8 is almost 3. Yeah, that's a volt and a half falling on that too. Even though the relative voltages aren't correct. Where am I at here? I'm proving everything works, but nothing works. Everything works, but nothing works. Sorry there, cat. Everything works, but nothing works. Well, I think I'm going to take a little break here and ponder the situation because not adding up at all. Let's take a closer look here and see if we can understand this whole arrangement better. Now we're in the broadcast band. These are the sections on a rotor that are rotating in and out of the circuit, and standard broadcast band is this one here. So this is the section that's rotated in against these contacts. And look, there's no parts, it's just wires, just shorting. So you're shorting 11 to 10 to 8. Well, here's the tuning capacitor here, and you'd be connecting this point right to the grid. So basically you got the tuning capacitor, and then what coil is it working against? This? Maybe. Boy, that doesn't seem very likely to me, but maybe, because it's just the front end of the radio. So perhaps the tuning capacitor is working against this coil. Located on main chassis. I'm pretty sure I know where this is sitting. And I think I know where this is too. They're very close together. And exposed. Although they're showing inside the box here. Wait a minute. Wait a minute now. Yeah, there's a note. Located on main chassis. Even though they show it as if it's in the box. Why would they do that? Why would? I guess a note is an easier, neater way to do it. So, okay, so so I know where this is. And this one, okay, they show it in the box, but I think this is accessible. But maybe not. It could be, I don't know what. There's another little trimmer located on the chassis right near here. It's probably this. Okay, so how does this help? So if we're in the broadcast band, which we are, then we would find the antenna connection coming through this coil, entering into here. Got a trimmer capacitor to ground here, or to the chassis. Not to B minus, but to the chassis. In fact, look at everything in this tuner is to the chassis. Okay. Okay, I lost him. I was going somewhere and then I detoured a little bit. So let's go back to what we were doing here. So these two capacitors, the tuner and the trimmer, are tied right to the grid here. And so this is the input. So the input comes here, and it's being resonated by this. And excuse me if I'm wrong, I think this little coil here doesn't make a lot of sense to me. Well, I guess later on the coils that the radio is resonating against is up in these things. This one, the coil is stuck out here. Could it be somebody fooled with this coil to the point where it's discombobulated radio? Radio's weak on all bands. Radio's weak on all bands. So what have I done here today? Today I have listened to the signal here and the signal here and found them to make sense. The signal here is strengthened at this point. I found the signal here to be basically the same as the signal here. I found the signal to be, I'm not sure I found it stronger here, but I think I did. What I really haven't been paying attention to at this point is the local oscillator. I've repeated this measurement. It's supposed to be -3 and it shows up as a positive. That suggests this tube is not oscillating. But why did I spend all this time this morning fiddling around over here? And like sooner or later you got to get a grip on this stuff anyway, so even if I venture off into the wrong woods for a while, it doesn't really matter. It all just causes a deepening understanding of the radio's circuitry in that, which is handy. Well, did I prove that everything is fine to hear? Have I proved that? Maybe I've got to repeat this just to get it clear in my head. So I now understand I can feed a signal in here, find it over here. We should be able to hear an ordinary radio signal at this point if the radio is operating, and we can't. We don't. We'll have to have a strong boosting of the signal. Well, and you know, that may come back to here. Should I fiddle with this? And which one is this exactly? C112. So it's suggesting it's, you know, they wouldn't put this in the box where you can't get at it. I mean, that would be crazy. All this stuff has to be accessible for tuning. You can't have the box apart while you're doing it. So these are right on the tuning capacitor. These ones here. This one here. G, F, and E, H, and I. So if we go looking for I, looking for I, be up here. Oh, on the top. So here's L3. On this radio, it's protected with a barrier. On the radio I have, it has the barrier. On my own radio, this is missing. The barrier protection is missing. Here it is. There's the capacitor. I fiddle with these two and see what happens. Let's look back at the schematic again. Oop, I like that. Back to the schematic. You know, this could be a trap. It may not be what I think it is. I don't even know what I think it is. We better look at the instructions for this L3 and C112. So we would want to look at the alignment instructions. Way up here, way up here. I think they're up here. Are they up here? Here we are, alignment instructions. Now we're looking for things I can't remember what they were. Oh. Aren't they putting the... Yeah, be kidding me. They're not putting the number here? The part number? Oh my gosh, really? Ah, I'm stunned that they didn't do that. Okay, back at the schematic here, or this part here, and so we're looking for L3 and C112. What are they called? They're not called anything on here. Oh, for crying out loud. How do they do this? Nonsense. So they're that's not going to help. C11 wasn't C11 anyway. It was C112. Did they name it here? C112. Where they got this listed somewhere special. 112. Trimmer. Just says trimmer. Oh, for crying out loud. Really? Come on. This can't be this way. Coil straps. Huh. Well, the dumb things here. This is kind of dumb. How are you supposed to relate this? Oscillator and RF select. How are you supposed to do this? Somewhere those words must be stated. Well, so if we pick an adjustable thing, it just says H, L3. Oh, these letters are the key. These letters are the key. I and H. So we want to find I and H. Okay. It doesn't show up. Well, this is not very helpful at all. I mean, this would lead. I mean, if unless I'm overlooking something, which I probably am overlooking something at this point. If this is what people face when they do an alignment on this radio, you either have to make a subsequent, like some kind of additional. Oh, here it is. Here it is. GHI right here, right here. So we're look. So look. So G is done. So H is done at 600, and I is done at 1400. Intended trimmer on side of tuner and loading coil. Yeah, that's them. So these are adjusting. I believe they're adjusting the local oscillator to make it fit on to make the scale on the radio accurate. And so you have to stretch it at both ends, the low end and the high end. But could these cause a radio to not work? I don't think they can, unless they're defective. But just being out of tune, could it? Well, no, because Jim, it's all about the oscillator not working. What are you doing again? You just, well, again, just learning stuff. Okay. And of course, all this is to come once the radio starts working better. Oh my gosh, am I ever lost on this? I'm going to take a little break here. Hey, Bert. Have you got any good ideas? No, he's got no ideas to help. What happened? Did we win? Did we win something? Shh, everybody quiet now. My cat's asleep here. So what I'm going to do is I'm going to call it quits here. Tomorrow I'm going to focus on the oscillator again and try to work my way through the circuit in some way. I don't know how. And that's about all I can say. So thanks a lot for watching today. Sorry it kind of just stumbled around, but yeah, that's par for the course, I think, at times. We can't know everything about everything. And you know, one of the best skills humans have is making decisions in situations where they really don't have enough information to do it. That's a skill we have, and we use it and employ it all the time and never think much about it. That's a little dangerous because part of that is reaching a conclusion quickly, and that's to enable action quickly, so we can get on with whatever it is we're doing. And there's a little bit of a danger in that. So the natural tendency is first idea, go with it, type thing. So I guess what I'm trying to say is doing this kind of work is a good exercise for a human being. See you tomorrow.